Hello and welcome to the world of NDE 4.0. My name is Johannes Rahner and today is a great because today we will continue our excursion into the world of ultrasonics. Today we will be talking about automated ultrasonic testing. Now, a couple of weeks ago, we started this excursion into the world of ultrasonics with the view into the early history. And in that early history, people started, they started using those instruments and started scanning components using their hand. And at the same time, looking what the instrument was showing to them. So if a peak was coming up on that screen, they knew, okay, that is most likely an indication. So what they did is, number one, they did the manual inspection, but on the other hand, they are doing a visual interpretation of the data live. And the only thing we can do to kind of sort for a documentation is doing screenshots. And if we look here at that instrument, at a very early instrument, that actually had something, you could adapt a camera to it to take those screenshots. Now on current digital instruments, that is actually a lot easier. Normally you have a button you just press, and that's actually what you get. Now, inspecting one of those components, those large forgings, then that can actually take a couple of days to a couple of weeks. So even from the beginning, it was clear, that mechanization could be a really good idea. So they started using motors to actually start rotating that component. And they had something to press that transducer against the component. And then they had a second axis going along the long shaft. But they were still doing this visual live interpretation of the data. And if they found something, then pressing the button and stopping the inspection, because then they had to look a little bit more in depth. Now, this is what I understand under mechanized. Some other people are using that term a little bit different, and I will come to that in a minute. Now, next step for me is automated inspections. Now we are using the same motors we used to use in the mechanized inspection setting, but now what we do is we actually record the data. So we take the ultrasonic instrument and hook it up to a computer. And for every shot we are doing on our component, we are not only recording our A scan or our ultrasonic data, but we are also recording the position. And normally we are positioning we are recording this on a two-dimensional grid, normally in a scan and in an index axis. Now, once we have recorded this information, either we could use it, we could record full high-frequency A scans, we can record normal rectified A scans, we could kind of record compressed A scans or C scans. I will come in a minute to what all those are. And then we actually display those A, B, C scans either live or also after the inspection, because now we have all of that data recorded. And then we can do the interpretation on that data. But again, this is a visual interpretation of that data. Now coming to automatic. Automatic, we are kind of using an automated system, but now we are going steps ahead. Now, this automatic is kind of what I will be describing is kind of what perhaps could be achieved in the long run. But there are a lot of steps in between. So what we could think about in automation is to have an automatic component handling, something taking that component and putting it into our inspection system. Or something, if we put that component on the system, that it also automatically measures the dimensions of the component or knows it from a database, and that helps to actually program our mechanics. Also, we can do an automated setup of our UT parameters. We can also go into automated data processing and interpretation, or even automated report writing. So you kind of see where I'm going with this. And before that, I talked about mechanized. Now, some people actually use the word mechanized for what I would call automated. And for what I know, this is mostly used in that way by some of the persons within the nuclear business and for some people within the rail business. But mostly this or most other businesses are using those terms like I described. Now, what we will be talking is automated inspection today. And the most simple component you can inspect with an automated system is kind of sheet material, something flat and rectangular, something like this. And what we can do, we can then put our probe on our component and then move that probe in something like this zigzag pattern. And we have one axis, which is the scan axis. So this is where we kind of continuously record the data. Then we index our probe, and then we again do the continuous data recording. We index and we do the data recording. So those are the two axes we are actually using for our inspection system. This is a scan axis and an index axis. Most of the ultrasonic instruments, even the ones available now, use this two-dimensional grid with an index and a scan axis. Instead of a meander, which we looked at here, we could also do something like a more comb-like inspection pattern. We'll move up, we move down, we index, we move up, we move down. Now, this inspection pattern, this is something, if we have really high precision measurements, then we get some hysteresis effects from the movement of our probe. So if we're moving up, we're dragging, and then we're dragging in the other direction. And then we are getting a little bit of offset in our data. So it might be better actually to do this comb-like inspection pattern. Again, we have the scan axis, and again, we have an index axis. Now, what we talked about up to the moment, we have a grid in our index direction. But also we have actually a grid in our scan direction, because what we have in ultrasonics is we have a certain pulse repetition frequency. We only shoot every now and then. Let's say if we have a 10 Hertz pulse repetition frequency, yeah, then we shoot every 10th, 1 divided by 10th second. So this looks like kind of this, shoot, shoot, shoot. So we are getting signals out of our component in equidistant scan positions. So finally, we are getting this grid, and on this grid, at every intersection of our horizontal and our vertical lines, we are getting one A scan. Now, what we can, number one, we are getting those A scans, and we can, during the inspection or after the inspection, look on every of those intersections within that grid, and then we see the A scan we are seeing here on the left. So that's the representation for one particular position here on our grid. And what we see on our A scan, yeah, that's typical. We are seeing the sound path. So that's the information into the component. And what we have to the top, yeah, that's the amplitude of our reflection. So what we see here, this is here an indication we see here. And you can also see already plotted two gates here. And what we can do is, now, if we take the maximum signal, which is coming above that gate, so in this, it would just be that one peak, and then we can actually plot exactly those points which come above the gate onto a two-dimensional grid, which represents our index and scan axis, so the surface of our component. We're getting this view into the component. Now, this is kind of a projection. We project all what is within the component we are projecting onto our surface. That's a C-scan. So what a C-scan is, on the one hand, we have our index direction. On the other axis, we have the scan direction. And what we see here, we also see different colors. Those different colors are the amplitude we are getting. So we have a color-coded amplitude. Now, the problem is if there is one big indication and a smaller one on a different sound path, then that big indication can be hiding the small one just on a C-scan, just because we're displaying the maximum amplitude. And that's where B-scans can help. Well, yeah, for sure, we can also look at the individual A-scans. But what a B-scan is, B-scans can help us get a quicker view. And what a B-scan does, if we think about that, such a plane through the component, a cross-section through that component, what we have on the one axis, we have our index direction. On the other axis, we have our sound path. Then we are getting such an image. So this is a cross-section through that component. And we can see those indications quite clearly on that cross-section. And then we can move from one cross-section to the next. And for each one, we will get a different B-scan. Now, there is a second kind of B-scans, and that is, the orthogonal cross-section to it. So now we are going along the scan axis and along the sound path. And again, we are getting such an image. So, and with those four views, the C-scan is mainly for the overview, B-scans for a more detailed analysis, and A-scan if we really want to look into that information we really want to have. With all that, we can normally do our visual interpretation of our results in a very good way. Now, not all components are rectangular. Like those here are rotor forgings, and I think you already heard in the past videos that I have worked in the forging industry in regards to the forging industry for a couple of years. So this is a picture of earlier me standing within all those forgings, all those big forgings. And yeah, if we want to do an automated inspection of such a forging, then we have such inspection systems. So we put that component on the inspection system. We start rotating the disk. We have the probes, which we see here on the right side, which are pressed against the component. And those can be, number one, conventional probes, but they can also be phased array probes. So we can mix them as no matter how we like. And once we come around one time, so this is our scan axis, then we index and we go around one more time and we index. So we can imagine this like this. We see here the probe here on top of our component, and then we rotate around, going around the back, and then coming up on the next lap. And that doing over and over. Now again, here we have this two-dimensional pattern. We have a scan axis, and we have an index axis. We can visualize that with the same A, B, and C scans. Now, the only difference is with the C scan or also the B scans, the scan direction is now not anymore in millimeters, but we are going one times around a round thing. So it is in degrees. It's going from 0 to 360. Now, if we want to do an inspection not from the outer diameter, but from the faces of that component, then we actually we put our component, our probe on here, and then we can move it in such an helix pattern until we reach the ID, or the middle of our component. In this way, now our circumferential direction is the scan axis, and the index axis is now our radial direction. And the axial direction is actually our sum path direction. Again, we can do C-scan of that. Again, doing from 0 to 360 on the one axis, that's the circumferential direction, and the radial direction from the radius of 0 to a radius of outer diameter, or outer diameter divided by 2. Now, this might be a little bit tricky to view because it looks like a stripe, and then what we have to do, we kind of have to bend it around in our head to actually make our round component. Now, a helix, in a lot of cases, it's a good idea because we have a continuous movement in scan and an index direction. But in some cases, we really want to stay on one lap, especially if we are coming to something like SAFT, so doing reconstructions. And then we have to go to something which I like to call a rotational meander. Again, we are going around on the scan direction, we're indexing, and going around again. And we can visualize that with the exact same A, B, and C scans we talked about before. So I guess by now you see that most ultrasonic instruments for automated inspections, they always use this two-encoder solution. One encoder for the X, or one encoder for the scan axis, and one encoder for the index axis. And we can not only use that for those kind of small discs, which are only about 5 tons of steel. Now we can actually use it also for such big shafts, such generator shafts. Those generator shafts, they can be up to 20 meters long, 2 or 3 meters in diameter, 200 tons of steel. An inspection, a manual inspection of such a shaft, I would guess somewhere within the 4-week range. Automated, perhaps 4 days. You can see a little bit the scale. If you look here at those steps going up, you see the scale of that huge shaft. Now, automated inspection systems, if we are looking at those discs and those shafts we looked at up to the moment, they are kind of, each of those components has a different dimension. If we are coming more to a serial production, an inspection system like those here, which have actually a lot more probes within that system, can be up to a couple of thousands of them, are quite reasonable. Or if we look here on this inspection system, this is a similar situation where we have kind of a serial inspection type. Now, what we can also see in this example, we are using, as a coupling, we are using water, or in some cases also oil, and you can see how the water is actually here in the back of that component. So we are using here still a contact inspections. We can also inspect such railway shafts, so railway axles from the inside with such a system. So we have a mechanic which is going inside, presses our probes from the inside against that shaft, and then we are doing the inspection from the inside to the outside. And we talked about contacting inspection, but we can also, instead of having the probe, a small gap of water, and then the component, we can actually put our complete component into the water and then do something which is called immersion testing. So we have a longer gap of water between our probe and our component, which makes it some of the parameters easier to adapt and some of the parameters actually a little bit more complicated. Like we have to avoid air bubbles within the water. We can also go to a solution where we are using a very strong pulse, or not pulse, a very strong water, which is actually shooting against our component. And in the back, we have our ultrasonic transducer. And that ultrasonic transducer actually excites a vibration within that water column, which is then actually brought into the component, and then we can do the ultrasonics like we know it. With this technology, what is really the fascinating thing, we can then use robots and actually inspect very complex shaped components. We can also do dual robot systems. So instead of doing a pulse echo mode, using a through transmission mode. This is here another example for robot-based system where we have this 6-axis robot and a 7th axis actually for actually tilting the ultrasound at the end. And this is another example of such a dual robot system, and you can see how complex the shape of such a component is and how those two robots have to move together to actually give a decent result. Now, coming back to the beginning, the ultrasonic instruments are still using an index and a scan axis. But now we are positioning our probes completely in a 3-dimensional space. We are also rotating our probes. So in total, each of those robots has about 6 dimensions. So at this point, it might come to the point that it might actually make sense to go away from a 2-dimensional encoder system to something like a 6-dimensional encoder system. And last but not least, here this example, also a dual robot system. This time, I think this is in contact technique actually. And we have here this huge robot arm, and we have here the tiny robot within the component. And those two have to move synchronous to actually come up with the results the customer needs. And you can imagine how precise those robots have to be so that the outer and the inner robot are going at the same speed at the same position. So, thank you for watching this video. Thanks a lot for the automated ultrasonic system suppliers like Actemium, Phil, Karl Deutsch, Robo Technologies, and Waygate, which allowed me to use their pictures in my presentation. And you will find the contact details to all 5 of those companies down in the video description. Now, if you need any further consulting on automated ultrasonic testing, you can actually either go to one of those 5, or you can also contact me, and we can see actually what could be the best system for your needs. The best system, perhaps we can also work on some automated data analysis. How can we store that in some database? How can we integrate such a system with an NDE 4.0 solution? If you have any comments, any questions, feel free to ask. Next time, we will go one step more into the details of automated inspections. We will get to the scanning grid. So how dense do we have to have our inspection points, both in the index and in the scanning direction? As usual, you will find more information in the description. I hope you like this video. I hope you subscribe to this channel. I hope you give me a thumbs up. I hope I will see you soon. Thank you for watching. See you soon. Thank you and bye.